All right, 4.3, ready, set, go. In the ready, it's preparing us for what is going to be coming in some of the future sections with the rational functions. So we're going to look back at some of the things that we did with polynomials. We use synthetic division to determine whether a given linear term was a factor. But I also showed you guys long division, and that is specifically what you need to work on here is the long division. It is important for 4.4, and it is also important in 4.6 and 4.7. So let's just do a quick review on the long division. So I will do number 1 with you guys. With long division, what you are dividing by goes on the outside. What you are dividing into goes on the inside of your house. So now I'm going to run through the process for division. You look at your first term and your first term. What do I need to multiply x by in order to get x cubed? If I multiply by x, I will get x squared. So I need to multiply by x squared in order to get x cubed. Please make sure you remember to distribute to both of those terms. So I get x cubed plus 2x squared. Part of long division is subtracting to get your next values. So I have to subtract both of these terms. So I subtract x cubed and I subtract 2x squared. X cubes cancel. 6x squared minus 2x squared gives us 4x squared. And then I bring down the 8x, the remaining terms. Now I'm going to go through this process again. What do I have to multiply x by in order to get 4x squared? I must multiply by 4x. You do have to be decent with your multiplication. So I'm going to distribute again, and I have 4x squared plus 8x. Now I must subtract. Oh, and they both cancel. Well, let me read the directions again. Use long division to determine if the given linear term is a factor. Because my remainder was 0, yes, it is a factor. If I did not end with 0, it would not be a factor. So it is okay here for these to not have a remainder of 0. It just means it is not a factor, unless you made a mistake. So take your time with this. Make sure your multiplication is good and you are attending to precision and not making mistakes. And also do not forget, if you are missing any pieces, you must use a placeholder. It doesn't look like any of these are missing anything, so we should be good there. But when you do miss something, for example, if this 9b was missing, you would put a 0b in its spot. So just watch out for those. All right, let's look at the set. So the set is similar to what we went over in class about what a rational function is. Look at your foldable for what a rational function is. So that should help you with answering 7. And also 8. Don't forget rationals have to have a polynomial in both the numerator and denominator. Spell it right. And in the denominator, you must have an x. So as you are answering 8, keep that in mind. It is on your foldable, the definition of a rational function. In 9, you are given a rational expression that has been simplified, and you need to find the one that she did correct. Angela made some mistakes. So you need to find the errors and you need to fix them. That's analysis. I need to look at the work. I need to analyze it. You need to know your stuff too in order to find those mistakes. You might want to start with A, B, and C and go ahead and start them from scratch from the beginning, and maybe you can find the mistake that way. Otherwise, you can just look at the work that's here. So I'm not going to do one of those with you because I would like you to attempt them on your own, please. In this next portion, what I do here might actually help you answer those 3 previous questions. Simplify each expression. With adding and subtracting, so in these first 2, please remember to get a common denominator. That's always been the case with fractions. Anytime you add or subtract, you must get a common denominator. Why don't I go ahead and do number 10 for you guys? So, actually no, I won't do number 10. 10's easy. 10 already has a common denominator, so I don't need to worry about that. Just go ahead and put those 2 together. But in 11, you do need a common denominator. So I have x plus 2 for one of my denominators and x minus 5 for the other. You multiply by the factor that is missing. So the left side is missing an x minus 5 and the right side is missing an x plus 2. So now I distribute. When I distribute, I get 2x squared minus 10x plus, then, oh man, this is a little bit tougher. This is x squared plus 2x minus x minus 2. All over my denominator, and leave them as factors. From here, you need to simplify, combine like terms in your numerator, and then see if you can factor and cancel. So I'm not going to take that one any further, but make sure you do factor and cancel those if you can. Now 12 and 13, there is a typo. 13, please use division for 13. Divide those. They are the exact same expressions, so the work shouldn't be too bad. One of the things you need to make sure that you guys are getting better at, please, is when you see expressions like this x squared plus 6x plus 8, you can factor these. And a lot of us are missing the things that we can factor. What multiplies to 8 that adds to 6x? 4 and 2. So x plus 4, x plus 2. Over multiplies to 4 and adds to negative 5, negative 4, and negative 1. Multiplies to negative 4 and adds to 3, x plus 4, and x minus 1, and then we have 2 and 2. So multiplication is done straight across. You put your numerators together, you put your denominators together. And at the same time, I'm going to look for things that can cancel out. So I can cancel an x minus 1 with an x minus 1. I can cancel 1 x plus 2 with an x plus 2. That's as far as I can cancel. So what's left in the top? I have 2 x plus 4s, so I can write that as a square. And then I have an x minus 4 and an x plus 2. There's my simplified answer. In 13, because it is division, please do not forget that you need to take the reciprocal of your second fraction. And it's already been factored for you, so this should not be too bad, but different things may or may not cancel this time. So be very, very careful here. And this next question, you're filling in those blanks. You're looking for similarities and differences between rational numbers, which are like 1/2, 2/3, 5/7, and then rational expressions. And rational expressions are values that have x with them. So like an x plus 2 over an x minus 7. So compare and contrast those types of things. And in the Go, you are asked to find all solutions to the following equations and inequalities, and then watch out for extraneous solutions. So extraneous solutions we need to remember are undefined values. The values that we are going to say they do not exist. And we only have to be careful for those in our rational expressions. So I'm only going to want you to do a small handful of these. Let me get rid of that for now. How do we get rid of a square root? We square both sides. So then I'm left with x plus 5 equals 16. You should be able to finish. Little bit different here because you have an inequality. In 17, you would need to divide by 2 first. Please be careful with those ones. Then you get to 18. Same thing, square both sides. Be careful because it is an inequality. In class, we have been working on what do we do when it is in an inequality form, and we've talked about this in previous homeworks where you've had to test values on a number line. So I'll go ahead and do 18 for you. I square both sides. I'm left with x minus 4. And I'm going to just change this to an equal sign with a 1. Then I'm going to add 4 to both sides. So x is going to equal 5. Now I'm going to test on a number line. Here's 5. It gets a closed circle because it is greater than or equal to. Now I'm going to test a value. I'm going to test 4 and I'm going to test 6. And I'm going to plug those into my original equation or inequality. So I have 4 minus 4 must be greater than or equal to 1. Well, what is 4 minus 4? That's 0. Is the square root of 0 greater than or equal to 1? No. So this piece does not work. Now if I plug in 6, 6 minus 4, the square root of 2, is that greater than or equal to 1? Yes. So this piece works. So my answer is where x is greater than or equal to 5. So that one, I could have left the inequality the way it was. You can also write this as 5 to infinity. I will take either one. For right now, I am not worried about 19 and 23. Not worried about that at all. I would like you guys to do 20, 21, and 22. I will do 20 with you guys. I have one fraction. So I couldn't do this with 19 because there are 2 fractions here, but I can do this with 20. I don't want that fraction, so I'm going to multiply by x plus 3, which will cancel it on the left side. So I now have x squared plus 9x plus 18 equals 2x plus 6. I move the 2x over by subtracting it, and I move the 6 over by subtracting it. Now I can factor. What multiplies to 12 that adds to 7? 4 and 3. So here x will equal negative 4 and negative 3. Here's where we have to be careful for extraneous solutions. Extraneous solutions happen where things cancel out. So I could actually start this one a different way. Then I don't make the mistake that I did make here by getting rid of my fraction first. Let's factor in the beginning. What multiplies to 9 that adds to 18? X plus 6, x plus 3. All over the x plus 3 that was originally there equals 2. Oh no. The x plus 3's cancel, which leaves me with x plus 6 equals 2. So x equals negative 4. So it turns out negative 3 was not a solution. The negative 3 is my extraneous solution. X equals negative 3 is the extraneous. So it's not a solution. Please be careful. Watch out for those. So if you can factor and cancel first, do that. If you can't, then go through the process that I just showed you at the beginning. And if you need to stop it and rewind this, then do that. So that way you guys can finish 21 and 22. If we have time later in class, we'll do ones like 19 and 23. And then you guys can answer 24. That wraps up 4.3. If you guys have questions, when you have a chance, come in and see me, or when we have our homework question days, please make sure you ask them.